Let's start by drawing a quadrilateral, ABCD. This is any quadrilateral, not necessarily a rectangle or a parallelogram or a rhombus. It can be any quadrilateral. Now let's mark the midpoints of the opposite sides P and Q. So P is the midpoint of AB, Q is the midpoint of CD. We can use P and Q to split the quadrilateral into two equal parts. Just join AQ and EC. This portion in the middle, the area of it is exactly half the area of the quadrilateral ABCD. And this fact can be used to design many beautiful problems in geometry. This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students. Let's look at one such problem today. So this particular problem says that PD and QB are also joined. Show that PXQY is equal to AXD plus BYC. This is the goal. This is what we want to do. First of all, let me explain why this portion in the middle is exactly half of the area of the entire quadrilateral. This is a very important fact and is used over and over in mathematical Olympiads. It's a very simple fact as well. You can easily prove this. Just join AC. Now since P is the midpoint of AB, therefore APC is half of ABC. APC is half the area of ABC. We know that median splits a triangle into two equal parts. Right? Similarly, AQC is half the area of ADC. Now if you add it up, you get APCQ, that is this particular quadrilateral, is equal to half sum of these two triangles, which is the entire quadrilateral ABCD. This is a very simple but powerful way to cut out exactly half area of any quadrilateral. Okay, now that we have established that this portion is exactly half the area of the entire quadrilateral, let's give names to different portions of it. Let's call this alpha, this one beta, and this one gamma. Okay, alright. So now let's call this red and let's call this blue. I often use these words to denote areas of different pieces of my geometry diagram. That can be very useful. Now see, red plus beta is half of ADB. Half of ADB. Red plus beta is half of ADB. And blue plus gamma is half of CDB. Half of CDB. So if you add these two up, you'll get red plus blue plus beta plus gamma is half of ADB plus CDB. ADB plus CDB, which is the entire quadrilateral ABCD. So red plus blue plus beta plus gamma is half of the quadrilateral ABCD. And on the other hand, we already know that alpha plus beta plus gamma is also half of the quadrilateral. We also know alpha plus beta plus gamma is also half of the quadrilateral. That's something we proved at the very beginning of this discussion. So red plus blue plus beta plus gamma is half of the quadrilateral, and alpha plus beta plus gamma is half of the quadrilateral, which means alpha and red plus blue are same. That's exactly what we set out to prove. We wanted to show that this particular portion is equal to the sum of these two pieces. But more importantly, the moral of this problem is how to cut out exactly half piece of any quadrilateral. And you can do it using the midpoints of opposite sides. And this is used in a variety of problems in mathematical Olympiads like AMC, IOQM, UKMT, INMO, and so on. Keep on doing good mathematics, and I'll see you in the next one, and have some fun with geometry. Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.